Okay, like I did an experiment just now, so let's go ahead and do the mathematical solution of that. So let me introduce the condition one more time. I have a hand, I'm holding a yo-yo. I let the yo-yo go down and it gets displaced by the height h. And in the meantime, when I push it back, I'm using the force F, which gets displaced by distance s. So that is the condition. So we want to find out the change in the total translational kinetic energy and change in the rotational kinetic energy. Now, let me ask this question. To find the change in translational kinetic energy, which system would be better, the real system or the point particle system? Well, as I explained earlier, in this case, the point particle system would be better because the real system involves not only translational kinetic energy but also rotational kinetic energy, but we know nothing about this. So we are trying to solve for translation first. So let's use the point particle system. So we are using point particle system. When we use point particle system, what is our system? The system is the center of mass of this yo-yo, right here, right? And the surrounding is hand and earth. Now, our work energy principle says what? Work equals change in energy. Now, to find the work done, which is F dot D, we're going to first find the net force acting on the center of mass of yo-yo. What are the net forces? There are two kinds of forces. One force due to hand upwards, and the next force downwards due to earth, right? So, when this force, so the net force will be F minus mg. I'm taking into consideration the direction upwards. That's why it's F minus mg. Now, what is our displacement dot D? Well, the center of mass. We're going to look for the displacement of the center of mass, not the displacement of individual forces, because this is a point particle system. The displacement of the center of mass is h. So D is h. If we use our work energy principle, F dot D will be F minus mg dot negative h, because it's in downward direction. Our net force is in upward direction. And solving that, we get mg minus F dot h, right? Now, the left-hand part of the equation, change in energy, deals with what? Since this is a point particle system, it only deals with a change in the translational kinetic energy. So change in the translational kinetic energy equals mg minus F dot h. That's how we can find the change in translational kinetic energy. Now, if we want to find change in the rotational kinetic energy, now we can't use a point particle system in this aspect. Why? Because the point particle system only deals with the change in translational kinetic energy, which we already found. Now, to find the rotational kinetic energy, we need to deal with a real system. Now, if we deal with the real system, what is our actual system then? Our system is not the center of mass of yo-yo anymore. It is a yo-yo plus a string. So yo-yo plus a string, this whole thing. Now, what are the external surroundings? My hand and the gravity downwards, right? Now, to find the total forces acting on this, because we are trying to solve for the work energy principle, which says work equals change in energy. Now, to find the work done, we need to first find the total forces, right? So what are the total forces? There are two kinds of forces acting. Force due to my hand and force due to gravity, which is downwards. Now, to find the work done, the right-hand side of this part of the work energy principle, our force F due to my hand, this point of application got displaced by distance s. So the work done due to my hand will be F dot s, not h anymore, because this is the real system and we're not looking at the center of mass, we're looking at the point of application of each forces. So force due to my hand got displaced by the distance s. And in the same way, force due to gravity got displaced by distance h, because the gravity always acts in the center of mass of the yo-yo, right? So considering that in aspect, those factors, so our work done will be what? Our work done will be F dot s due to my hand and negative mg, which is downwards, dot negative h, which will give us mgh. So this is our total work done. So what is then right hand side? The change in energy. There are two kinds of energy, as I mentioned earlier. The change in the translational kinetic energy and change in the rotational kinetic energy. Now, the translational kinetic energy we just found, change in the translational kinetic is mg minus F dot h. So change in the translational kinetic will be same for both systems. So we can use this on change in translational kinetic energy here. So far as the change in rotational kinetic energy, which we are trying to find, and the work done is on the right hand side. So to solve for the change in rotational kinetic energy, we do F dot s plus mgh, and we bring this to the right hand side. The mgh and negative mgh cancel out, so we are left with F dot s plus F dot h, which is equal to F and then s plus h in parentheses. So this is how we can break down the movement of yo-yo into two systems, the rotational, the point particle system and the real system, and describe the work energy principle associated with it. To find the change in the rotational kinetic energy, we can find the velocity also, we can find the change in the translational kinetic energy, and many things. So it's a cool thing. Thank you very much.